All right, students. So this question is from the chapter of current electricity. And as you can see, the question is all about the concept of equivalent resistance. So each of the resistance that you see is 2 ohms. Okay? 2 ohms, 2 ohms. All of these are 2 ohms. You have to find the equivalent resistance between A and B. Okay? I'll just enlarge the question so that you can read it, and then I will decrease the size. Okay? So this is the question. Have a good look at it, and then I will reduce the size and we will start solving it. Okay. Okay. All right. So, what's the first impression you get when you see such a circuit, right? The first impression I got was, there are some series in parallel, and we will be able to solve it. And my first impression was partially correct because if I see this particular part of the circuit, this part and this part, right? So I can say that these two are in series and these two are also in series. Okay, so let's say these two are in series and these two are also in series. So that part turned out to be correct. Okay, so this is your two and this is two. 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 But when I look at so this is simple, right? This is series. This is also series. These two are in parallel. This is in series. This is in series. And these two are in parallel. Can you always find the answer, right? So answer is 2 plus 2 is 4. And this is 2 plus 2 is 4. 4 and 4 are in parallel. So 4 into 4 divided by 4 plus 4. So you get an answer of 2. So this is 2. This is also 2. So this is pretty much done. Now let's move forward to the 4 squares that you see. Now this is the difficult part of the question. Okay, how do we break down something like this and can see this in a more simplistic manner, right? So if I want to solve this, so this is what I will do. I say that from A to C, okay, A to C, the resistance is 2 plus 2, 4, 2 plus 2, 4, 4, and so this is 2 ohms, and this is C, and on the other side, let's call it D. Okay, so this is your D, and this is also 2 ohms, right? So this is no brainer, right? This was the simple part of the circuit, no brainer, right? So you have a 2 ohm and a 2 ohm, and then what you have is this complicated part which needs to be addressed. Okay, let me redraw this circuit and then we will discuss how do we address this. For the time being, I am removing these two, which are the small squares. Let's remove that and let's just focus on the part which is more complicated. Okay, so I'm removing this 2 ohms and 2 ohms. Okay, but I'll retain the naming convention which is C and D. Okay, so this is C, and if I draw a circuit here like this, okay, then I will draw a circuit like this. I'm just redrawing this, but this time around, the only thing I'm doing is I am drawing it in a way. Remember, this is 2, this is 2, this is 2, this is 2, right? So even these two become 4. This is 4, and this is also 4. So very simple, right? So far, so good. Okay, so this is the point C we were referring to. On the left hand is 2 ohms. So we are talking about this point. Okay, so this is another point, and this whole thing becomes sort of 4 ohms, right? So I will just draw a 4 ohm here. So I've drawn this square. Now what I'm going to do is I'm going to draw this particular part of the circuit. This is 4 ohms, and this square also needs to be completed. So this is 2 ohms, this is 2, right? Kind of congruency, right? So this is 2, this is 2, this is 2, and therefore this also is 2. Okay, so this is 2, and this is 2. Okay, So, and this is 4, right? This is 4. Okay, I've just used a small wire to connect. This is just a connection. Otherwise, this point to this point is a common point. Okay, and of course, on the if I want to name this, this is C, and I can easily label this as D, right? And so the circuit looks like this partially. This is your 2 ohms, and this is your 2 ohms, right? And this is 2, 2, 2, 2, 2, 2. So when you look at this circuit, right, this circuit looks difficult, right? I really cannot go with my first impression of parallel and series. The next thing that came to my mind was, is it like some kind of Wheatstone bridge? But when I compare a Wheatstone bridge definitely has some common elements, but a Wheatstone bridge, I thought maybe this is some kind of Wheatstone bridge, and this is 2, 2, 2, 2, and I can ignore the middle one. But I really couldn't find any Wheatstone bridge here. So look at the level, look at the way I think about this problem. So the moment I see the problem, I see it as a series and parallel resistance problem. Then I start thinking about the different circuits which are taught to us. One of the circuit which is taught to us is, of course, the Wheatstone bridge. So I start thinking in terms of Wheatstone bridge. Doesn't work, right? Now, what do I do? What I now think about is a advanced level concept, which is already there in my playlist, called a symmetry of circuit. If I see this circuit, right, there is, if I split this circuit here, for example, right, so let me just split it here, okay, perpendicularly. It's identical, right, on both the sides. If I also split the circuit on this side, it is identical. And similarly, if I split it here, it is identical, right? So you can see there are many, many planes at which it exhibits the characteristic of the symmetry. Okay, so symmetry is a very important topic, and we will try and solve this question with our last technique. Right, I'm going layer wise thinking, and my last layer of thinking now is, can I apply symmetry? And I do find some symmetry here, which I will apply. Now, before that, I will just draw a simple circuit for you to understand. Okay, so this is my circuit, and so let's draw the circuit first. Okay, so this is one resistor. This is a second resistor. This is another resistor, and this is another resistor. Okay, and what I do now is I draw a resistor here. Okay, this is pretty much a very close to in fact, a Wheatstone bridge only. But what it teaches you, okay, though though in this case there is no Wheatstone, right? There is no Wheatstone here. But what are we going to learn from this point is the symmetry. If you notice, this circuit is symmetrical around this point, right? And therefore, these 2 points are at the same potential, which is what Wheatstone also tells. But forget the Wheatstone for a while. The symmetry is there, and therefore, these 2 points, club together, become a single. They have same potential, and therefore we can ignore this particular resistor. This is the concept of symmetry. It's an advanced level concept, but for those who are preparing for NEET examination, JEE Mains or JEE Advanced, you should know. In fact, in CBSE board also, you can expect something like this. Okay, because they're asking difficult questions. Very unlikely, but you should know about this problem. So if you look into this circuit of ours, right, and let me just remove the lines. This circuit is symmetrical, right? So I'll just rub off some of the stuff which I've drawn. Okay, so this is the stuff which I will rub off. Okay, so that we don't get confused by the color. Okay, so this is the stuff which is going away, right? So when this goes away, okay, I'm just redrawing the circuit. Just redrawing the circuit. Okay? So don't worry. So this remains as is. Since we have established there are multiple layers of symmetry, what we need to do is we need to find equipotential points on this in a similar manner we did here. Okay. If I see the this point, okay, let me call it the point number. So this was D, this is C. Let's call it E. Let's call it F, G, and H. Okay. I told you this is just for the purpose of I can just redraw this and connect it here directly. Right. So these are the two triangles. Okay. This is a triangle. This is another triangle. Okay. Now if the current passes through this point, okay, if the current passes through this point, when what it sees in front of it is identical circuits, the upward circuit and the downward circuit. So there are identical circuits through which it can go. The points E and G are the equipotential points. The point F and H are the equipotential points because from the current which entered and got split into multiple arms and stuff like that, the identical nature, the drop would be same. As the current progresses, the drop from CE will be same as the drop from C to G, and therefore these 2 points will merge. They become equipotential. So, so I hope this is making sense. The current is going in. It sees a symmetry. When it sees the symmetry, at that moment of time, it says what are the the equipotential points which are available to me. And I can do a small intuitive kind of work here, which is the potential drop. In fact, when the current proceeds here, right? Still, by now, although we don't have to calculate this, but we get this from experience. As the current progresses, even F and H are at the same potential. Okay, so E and G are at the same potential. We can merge them, and then F and H are at the same potential, and we can merge them. Okay, I hope this made sense to you. Okay. Just give me 1 second. Okay. Hello. All right. So let's move on this question again. So these are like equipotential surface. What do we do now? Let's redraw the circuit with a new knowledge that has come from the concept of symmetry. Symmetry has helped us in a certain manner. So just get rid of this circuit and let's redraw this circuit. Okay, especially the middle part is important, right? This 2 and 2 is, I mean, it's solved, right? So let's look at C. Okay, let's look at C and see what we can do. C, 2 and 2 are in parallel, right? So I draw a 2 and a 2 in parallel, these two. Okay, so these two I've drawn. This is 2, this is 2. And then what I do is the point E, which is the end of this, right? This is the point E. I have to draw a 4 ohm here. So I have drawn the 4 ohm, which is EF. This is E and F. So this is C and E. Okay. So this started from C and this is E, right? So this point is also E, right? This is just a conducting wire. Okay. So E, and let's do the same thing down below. The resistance arm again starts from C, which is this point. So I've already done that, right? I have already taken these to be in what? Parallel. Similarly, from E, I can draw 2 more parallels, right? So this is another place I will draw 2 more parallels, right? So this is 2 and this is 2 and this is 4 ohms. E is going to F. E and G have merged. Okay, E and G have merged, and the point. So E and C are this. C and E and G have merged. So C and the point number E, they have also merged. Okay, so I can draw this maybe in a more sophisticated manner. Okay, so these two are in parallel. Okay, so these two are in parallel. And okay, so what about the termination of this point, right? So these two, these two are terminating here, which is O. So let's call this as point number O. If I look into F, right? If I look into F, I have F and H, which are again, which I need to collapse. Okay. So I have another point which is G, okay, G, CG, CG, right? So this is CG, and I know I have a 2 ohms here. And I will just redo the same thing there, right? Because it's O, and from O, what I have to do is I have to draw 2 ohms, and okay, and then 2 ohms. Okay, so I have taken care of this and this. I'm just repeating what I just did here. Okay, I'm just copying it and repeating what is on the left hand side should reflect on the right hand side also. Okay, and of course, I will have one more structure here, which is like this, and which actually terminates at G. And this is my point H, right? So I have to put an H here. Between G and H, I have 4 ohms again, which I am going to draw as 4 ohms. Okay. Right? And these 2 points are one and the same thing, right? So I can merge them like this also, right? So all these are getting terminated at a common point, right? So these two are in parallel, these two are in parallel. And on the right hand side, where these two are in parallel, the 2 ohm and 2 ohm are in parallel, right? So we have to draw these two also in parallel. And then, so these two are in parallel. These two are in parallel. So it's identical. 2 ohm, 2 ohm, 2, 2, 2, right? And this is also 2 ohms. Let's now what we do is now we will calculate. So this is 2 and 2. So what will be the answer of these two? 1 by 2 plus 1 by 2, 1. 2 into 2 divided, right? So this will become 1 ohm. The second one, okay, let's see what happens to that. The second one is also 1, and the third one is also 1. And here we have 4 ohms and another 4 ohm, which is this getting connected, and then we have another 1. Okay, and then we have another 2. Because we know the answers to these two. So the answer to these two is also 1, and then this 2, right? So this is both of these become 1, and both this also becomes 1. They are in the same straight line. So they become 2 and 2, 1 and this 2 and 2 has become 1. Okay, so this 2 and 2 have become 1. These two have become 1. Okay, and these two have become 2. These two have become 1. Right? This is the overall circuit. So this is 4 and this is 4. Right? Slightly complicated. I hope you can see it clearly. Okay. Now let's redraw the circuit. So this is 2, 1, and then you have 2. So these two 1 ohms have become 2 ohms. This is 4. This is 4. So this is 4, 4, 2. And this has become 1 and another 2. Right? So this is 3 and 3 is 6. Okay? And these three are in parallel. So 1 by 4 plus 1 by 4 plus 1 by 2 is equal to 4. 1 plus 1 plus 2. is equal to 1. So R equivalent is 1. So the answer to these three is 1, right? So 2 plus 1, 3. 3 plus 1, 4. 4 plus 3 is equal to 6. Solved. Okay? Sorry. 4 plus 2 plus 1, 3. 3 plus 1, 4. 4 plus 3, 7 ohms. Very good question for those who want to learn advanced level circuit analysis for JEE Mains and JEE Advanced, but you can get a small version of this question in NEET also. That can come for in your examination. Okay, so go to my playlist and watch some videos on electric circuits and current electricity. You will find numerous such concepts which will help you simplify very difficult looking circuits. Okay, so don't forget to subscribe to this channel. You will see some fantastic conceptual questions coming from this channel. I already would have 100 plus videos on the topic of electric circuits where almost all the concepts have been covered. Go and watch them, go and watch the shorts. Also, don't forget to join my community because I'm putting some extraordinary, competitive exam like questions which are very conceptual in nature along with the solutions in my community tab of the YouTube channel. So go there and we take part in that, and you will feel very good because every day you will find people commenting and you will learn something new out there. Okay. So thank you very much for your time today and wait for my next video.